Okay, in this video we're going to look at one example, okay, of the electrolysis of a molten ionic compound. Okay, so in this case we have molten lead oxide. So let's say you were asked to draw the apparatus setup. So the way that you can do this is by first, again, remember to draw the power source. Then you have the wires that is connected to the electrodes, okay, and then you have the molten electrolyte, okay. So how do we make the ionic compound into molten ionic compound? Okay, so we usually apply heat, okay. So again, you have these electrodes that is made from graphite or platinum, but usually it is we use graphite, okay, carbon. So this electrode is connected to the negative terminal of the battery. So this is again same thing. This is called cathode. Then when you have the electrode that is connected to the positive terminal of the battery, this is called anode, right? So the electrolytes, you have molten lead oxide, okay, lead to oxide, okay. So you have to remember, so kenapa lead to? So lead to here in reference to the oxidation number of the lead itself, okay. So how do we figure out the product? Okay, so remember the first step, determine the ions, okay, determine the ions present in the electrolyte. Okay, so this is the first part lah. Okay, so let's use another color. Okay, so we know that since this is molten ionic compound, there are only two ions present. Okay, so it should be the positive and the negative ion of the compound itself. So in this case, so you have the metal which become the positive ion. So lead 2, it means the ions present in this electrolyte is Pb2 plus. Okay, so lead ion. Then you have oxide. Okay, oxide O2 negative. Okay, so in this electrolyte there are lead ion Pb2 plus and you have oxide ion O2 negative. Okay, and then the second step. Okay, the second step is where you need to determine. Okay, if we scroll this up, okay, remember the step, determine the electrode. Okay, so it means we need to determine which ion will go to which electrode. So this is, I would simplify this as the opposite attracts. Okay, so we know that for positive ion Pb2 plus, lead ion and oxide ion will go to the terminal, we go to the different electrodes. So lead ion, since it has a positive charge, it will go to cathode, which has a negative charge. So meaning cathode ni ada is a negative terminal. And then you have oxide ion O2 negative, it will go to anode because it is a positive terminal. Okay, and here you can write ion that move to anode. So anode siapa tadi? Oxide O2 negative. And then which ion that goes to cathode? This Pb2 plus. Okay, and step number 3 is where you need to write the formation of the elements. Okay, formation of the elements. So in this case, we can represent the formation of the elements by looking at by writing the half equation ataupun the equation that has happened at the anode or cathode. Okay, so that's why it's called half equation. Okay, sebab half means setengah lah. So kan, so setengah tu maksudnya what happen dekat equation yang happen dekat anode, what is the chemical equation that happen at cathode. Okay, so this is why it's called half equation. Okay, so now at cathode, what happened there? So again, Pb 2 plus. Okay, lead ion will become lead element, lead atom. Okay, so nak form lead atom, since we know that metal ion, okay, has a positive charge, meaning it has it already has lost its valence electron. Kan? So in this case, nak jadi atom balik, it must receive 2 electrons sebab dia punya charge is 2 positive. So you dapat Pb. Okay. And at anode, dekat anode pula, again, oxide ion will turn into oxygen, okay, element, maksudnya atom. Tapi kita kena ingat, oxygen is a gas, so it and non-metals, okay, for example like oxygen ni cannot exist as monoatomic atom. Okay, dia tak boleh single as exist as a monoatomic gas, so it is not an atomic monoatomic gas, so it must exist as diatomic gas, which is a molecule. Okay, sorry, I might use that term wrong. Good. Tak apa, just ignore that. Sorry. So anyway, so oxygen tak boleh exist as O saja. Okay, it must exist as O2. Okay, so this is the element of oxygen. So it exists as a molecule, right? So in order to do that, the oxygen ion must lose 2 electrons, okay, to form that. Okay, so 2 electrons. But now itu kalau satu oxygen, okay, satu oxide ion. But in this case, nak make O2, you need to have 2 oxide ion. So 2 oxide ions will give away, instead of 2 electrons, it will give away 4 electrons. Okay, so this is the half ionic equation. Okay, this is the half ionic equation that happen at anode and also at cathode. Okay, so what is formed, okay, at anode? So at anode tadi we have the formation of oxygen gas. Okay, so at anode kita ada oxygen gas form. Okay, kalau diminta pasal observation, what is the observation? We must say bubbles, or kalau gas tu ada warna, we can mention about the color of the gas. Okay, tapi kita tak boleh cakap oxygen gas form. Kalau diminta observation, kita cakap oxygen gas form, the answer is wrong. So observation means something that you can see. Okay, so that's include bubbles formation ke, color of the gas ke. Okay, so you must mention that. Right, so that is for observation. And at cathode, okay, at cathode you have the formation of lead metal. Okay, lead metal. So the observation would be solid deposited on the electrode lah. Okay, so you akan nampak there's an increase in size of the electrode tu. Maksudnya solid tu dah form dekat solid dah form dekat around the surface of the electrode, okay, of the cathode tu tadi. Alright, so bawah ni overall equation. So this is where you combine all of this. Okay, you combine all of this to make a single equation, but you guys don't need to know about that. Okay, so kalau you nak try, you can try, and then nanti you show me the answer and then kita check. Okay, but the most important thing here that you need to know is all this step. So from knowing the ions present, knowing which ion go to cathode, go to anode, and then you need to know about the half equation. Okay, what happened? Okay, the half equation that happened at cathode, equation that happened at anode, and also the product. Okay, that is formed. Okay, and also that includes the observation lah. Okay, so this is the observation. Okay, and this is the product that is formed. Okay, so that is another example. Okay, so kita stop sini dulu, and in the next video I'm going to show you the process, the work flow to determine the products for aqueous solution of an ionic compound. Okay.